Hello, everybody. Welcome back to the Tuition Center. I hope you did okay in paper two. You found that you were ready for it. You got stuck in on the day, and you kind of hung on in there through the difficult parts. You're now, I suppose, you have the marking scheme in front of you, and you're ready to correct it. Okay. So we're hoping that this video is going to be of use to you. That these series of videos of each of the questions are going to help you if you're stuck anywhere. So you're listening to Owen O'Leary. I'm here with Andrea Foley. Hello, Andrea.
Hi everyone.
Andrea is in charge of our free pre the construction of the papers and the marking schemes, together with a team of us here in the Tuition Centre. We've been working on these. I suppose we've been doing it for a number of years now at this stage, down in Bandon in Cork City, and I suppose we're now gone out to the nation. So, Andrea, we're hopeful that the students got through paper two okay,
Oh, absolutely, yeah.
and we'll we'll start off here on question one, and we'll go through it, and hopefully we'll be answering any questions that you came across in terms of how many marks to allocate to each part. Okay, here we go with question one. So, question one, it's an interesting question, a probability question. A manufacturer carries out a survey of defects in their soft toys. It is found that the probability of a toy having poor stitching is 0.03, so 3%, and that a toy with poor stitching has a probability of 0.7 of splitting open. So a toy, 3% of these toys have poor stitching, and 70% of that 3% are likely to split open. A toy without poor stitching has a probability of 0.02 of splitting open. So we know that, like, if 3% have poor stitching, that means 97% have good stitching, if you want to say it like that. And from those with good stitching, only 2% of them will open. Draw a tree diagram to represent this information. So here we go. With a question like this, I always say to students, you got to work out the logic, then work out the maths. So the logic here you can be helped by drawing the tree diagram, sketching it out. It might kind of come to you as you draw out the branches. So the first thing is there poor stitching or is there good stitching? So poor stitching is at 3%, 0.03. I suppose as a decimal, that's the likelihood of poor stitching. As I continue on up this branch, once you have poor stitching, you have two options. The stitching could split or not split. The probability of splitting is 0.7, and of not splitting then is 0.3, because the probability of splitting is 0.7, 1 minus 0.7 is 0.3. That's the probability of it not splitting. The probability of good stitching is 0.97. If you have good stitching, the probability of it splitting is 0.02, so the probability of it not splitting is 0.98. That's a 5-mark question.
So this one's marked on a 0, 3, 4, 5 scale. So for low partial credit, we're looking for some work of merit. And an example of that would be any correct probabilities on your tree diagram. So if you've drawn out your tree diagram or some of your tree diagram and you've assigned probabilities. So you could have drawn the whole tree diagram and only put one probability on. That would be low partial credit. Or you could have only drawn the first branch of the tree diagram and put on a correct probability. That would also be low partial credit here. For high partial credit, which is 4 marks, we're looking for a fully correct tree diagram with only 1 or 2 mistakes. So if you have drawn out your diagram correctly, but you've accidentally got 1 or 2 probabilities wrong, that would get you high partial credit here for 4 marks. And then the full 5 marks are for the fully correct tree diagram labeled with the correct probabilities.
Very good. Okay, so hopefully we have that, because that's going to lead us directly into part B, which says find the probability that a randomly chosen soft toy has exactly one of two defects: poor stitching or splitting open. Okay, so you might want to read this a couple of times before you try a question like this, because it says has exactly. one of the two defects. So in some ways, it's an unusual type of question because it's saying, what's the chances that you have either poor stitching and does not split open, or good stitching and does split open? So it's kind of the opposite of what you would imagine, because naturally you're thinking if it has poor stitching, it has a good chance of splitting open, which it does. But we must think about this. So we're saying our two scenarios here, our two cases are that you can have poor stitching and it not split open, okay? Or you could have good stitching, but it does split open. So those are the two kind of outcomes that fit the bill here to have exactly one of the two defects. So now, with the first one, the probability of poor stitching is 0.03. The probability of not splitting open in that case is 0.3. With our next one, the probability of good stitching is 0.97, and the probability of not splitting open is 0.02. Okay, so I think this is just a little typo here. Let me just change that to 0.02. Okay, and because it's case one or case two, I'm going to be adding these two guys together. And when I add these together, I get 0.0284. 0.0284. Okay, that's 5 marks.
So again, this one is a 0, 3, 4, 5 scale. So for low partial credit, we're looking for work of merit to find the answer. So that could be either of those calculations. So you might have had the 0.03 times 0.3 or the 0.97 times the 0.02. Either of those would get you low partial credit. For high partial credit, it's one error in calculations. So that's for the 4 marks. So that could be that you had one of the 4 numbers in the sum wrong, or you didn't add them, or whatever it may be. But if it's only one error, then it is 4 marks for high partial credit.
Okay. Okay. So hopefully you're doing okay in there, and you're still with it at this stage. It turns out that, as is often the case with the Leaving Cert Maths, sometimes in the middle of a question is one that's relatively straightforward. I think that's the case here with part C. So there's a new bit, an extra bit to the story. The manufacturer also finds that soft toys can become faded with a probability of 0.05, and that this defect is independent of poor stitching or splitting open. A soft toy is chosen at random. Find the probability the soft toy has none of the 3 defects. So therefore, for it to have none of the 3 defects would mean that it has what we say good stitching, it does not split open, and it does not fade. So if the probability of fading is 0.05, the probability of not fading is 0.95. We already have came across these two other guys already. So when we multiply those 3 together, we get our answer of 0.90307, and that's 5 marks.
So again, this one's marked on a 0, 3, 4, 5 scale. Low partial credit here is work of merit to find the answer. So say you'd written 0.97 by 0.98 and you hadn't done anything, excuse me, with the 0.95, then that would be low partial credit for 3 marks. Your high partial credit is one error in calculation for 4 marks. So that could be if you'd written down 0.97 by 0.98 by 0.05 instead of by the 0.95, that would count as one error in calculation and therefore would be high partial credit. This question does ask you to round to 5 significant figures. So it is a starred question, which means you drop 1 mark if you've rounded incorrectly.
And so in the exam, Andrea, it said to 5 significant figures. Are we right?
It did. Yeah, absolutely.
Yeah. Yes, exactly. I don't think I put this in the screen here, but I didn't mention that. But you had to have it all the way to 0.90307. Okay, so find the probability that a soft toy has exactly one of the 3 defects. So now again, back to the sentence I often use for probability. First, you got to work out the logic, then you got to work out the maths. So exactly one defect. So let's take the cases case by case. So case 1, case 2, case 3. In case 1, you have good stitching. Okay, here's your defect. okay? It does split open, but it does not fade. In case 2, you have poor stitching. It does not split open, and it does not fade. And in case 3, you got good stitching. It does not split open, but it does fade. So it does fade. So if I look at any particular case, I'm saying, if I look at case 1 again, I'm saying, what's the probability that it has good stitching and it splits and it does not fade? So I'm multiplying those together. And then when I take my 3 cases, because there's one or the next or the next, I'm adding the 3 total answers together, and I get a final answer here of 0.07451. And that was a 10-mark question.
So this one is marked on a 0, 4, 6, 8, 10 scale. So low partial credit here for 4 marks is work of merit. So an example would be if you had one of the 3 sums correct. So 1 bracket correct would count as work of merit. Work of merit would also be parts of more than 1 bracket correct. So if you had 2 parts of 2 brackets correct, say, by bracket, sorry, it's bracketed in the scheme. I mean the lines of work there, case 1, case 2, and case 3. So if you had all of case 1 correct, that would count as work of merit, but you didn't have case 2 or case 3. Or if you had part of case 1 correct, part of case 2 correct, that would also be work of merit. For mid-partial credit, which is 6 marks, we were looking for 2 of the cases correct. So if you had 2 of them correct and you added those and you didn't do the last one, that would count as mid-partial credit. And then your high partial credit is correct method, but 1 error in calculation. So if you had just 1 slip somewhere in there, you accidentally put in a 0.95 instead of a 0.05, something like that, that would be 1 error, which would be high partial credit for 8 marks. This question does ask you to round to 4 significant figures. So it's a start question and 9 marks available if you rounded it incorrectly.
And as always, they never, you just hate to look back and have lost that 1 mark. And I suppose what we're trying to get the students to experience by correcting the exam themselves is maybe to be in the situation of the teacher when you see the student losing that mark, and you're disappointed for them, and
Yeah.
they'll be kicking themselves if they're in that situation.
Absolutely, yeah.
Very good. Okay, so we finished with question 1, and we're about to move on to question 2.